Next, we're going to take a look at number 3 from the practice test. It says exactly 1 mole each of H2, I2, and HI are placed into a 2.0 liter reaction vessel. And then it gives us the reaction. It's H2 plus I2, back and forth the arrow, 2 moles of HI. And it says exactly 1 mole of each is placed into a 2 liter reaction vessel. So that means we have initially a concentration, so concentration of H2 equals the concentration of I2 equals the concentration of HI, and they all equal 1 mole in 2.0 liters. So that means the concentration of all 3 of those is going to be 0. Now let's see, what did it say exactly? Exactly 1 mole in a 2.0 liter container. So that's 2 sig figs, so 0.50 molar for all of those. And then it wants to know, what is the reaction quotient of the initial system? Well, based on this balanced equation, Q would equal the concentration of HI squared over the concentration of H2 multiplied by the concentration of I2. Since they are all 0.50, Q is going to equal 0.50 squared over 0.50 times 0.50. And Q is going to equal 1.0. So question A, what is the reaction quotient? There's our reaction quotient. B asks, which direction will the equilibrium shift? And it tells us in the question, at the reaction temperature, KEQ equals 64.0. So if KEQ equals 64.0, then Q is very much less than KEQ. That means at our current 0.50 molar of everything, this is too small, and this is too big. So some of these reactants need to break down and form more of the products. So which way is the equilibrium going to shift? Answer to B would be towards the products. Then question C really gets fun, because this is a kind of more tricky icebox problem than we've seen before. It says, what are the equilibrium concentrations of each substance once equilibrium is reached? So we know that it's going to be shifting towards the products, and we know that initially the concentration of all of these was 0.50 molar. So we're used to this being 0, right? And it just being a dead giveaway that it would shift towards the products. This time we had to calculate Q to figure that out. The change is going to be, so since we said it's going to go towards the products, these are going to decrease by some amount. They would be the same amount, so same variable can be used, minus x. And for every x amount that H2 and I2 decrease by, HI will increase by 2x. And so at equilibrium, we would have 0.50 minus x, 0.50 minus x, and 0.50 plus 2x. And now we can plug these into our equilibrium expression and find what this x would equal. Once we know what x would equal, then we would plug those into these values here to figure out the equilibrium concentrations. So I need to make some board space, and we will plug those numbers in. So KEQ is going to equal the concentration of HI squared over the concentration of H2 times the concentration of I2. We know the value for KEQ. It is 64.0. So we've got 64.0 equals this stuff from down here. So it's going to be 0.50 minus 2x squared. And we've all seen this done before, so we'll just skip right to it. It's going to be 0.50 minus x times 0.50 minus x. So rather than write that in times itself, we are going to just write it in as 0.50 minus x squared. To take care of those squareds, we will take the square root of both sides of this equation. Square root of 64 is 8. We'll go 8.00 to honor sig figs equals 0.50 minus 2x over 0.50 minus x. Multiply that over, so we end up with 4.0 minus 8.00x equals 0.50 minus 2x. We can then, oh, what did I do wrong? This should be plus 2x, shouldn't it? Ah, Bix, you idiot. All right, at least I caught it there. So that would be plus 2x, plus 2x, plus 2x. So then we are going to, let's do two algebra switchemaroos at the same time. We will subtract 0.50 from both sides, and we will add 8x over to each side. So then we end up with 3.5 equals 10x, and so x is going to equal 0.35, and then that would be molar. Now, 0.35 is not the answer. Remember, 0.35 is how much these guys are going to change. So, at equilibrium, hydrogen is going to be 0.50 minus 0.35, and so that means at equilibrium, hydrogen is going to equal 0.15 molar. And that's an answer. Same thing for iodine. It'll be 0.50 minus 0.35, 0.15 molar. And our HI will be 2x, so that would be 0.70 plus 0.50, so that's going to be 1.2 molar. And there's our answers.